Oh, it's a wonderful day today, and welcome to this session on sets. Today we'll be looking at members, complement, subsets, union, intersection of sets. So we have a lot in store. But as usual, we're going to go into God's word. In Psalm 71, verse 1, it says, "In thee, O Lord, do I trust. In thee, O Lord, do I put my trust. Let me never be put to confusion." And my declaration is, "O Lord, I put my trust in you, and I will never be put to shame." I'm Teacher Walton. In question 1, we are given some sets in question 1. You are given your universal set, and members of those sets are 4, 8, 12, 16, all the way up to 36. And I would want to say here that this set really is the set of multiples of 4. And we are going up to 36. So that is your set U, and we are seeing here that set consists of the numbers 4, 8, 12, 16, 20, 24, 28, 32, and 36. That's all multiples of 4. And set F would be the factors of 24. Do you know the factors of 24? I'm sure you do. 1, 2, 3, 8. We left out 1 before 8. Let's put in 6. 1, 2, 3, 4 is also a factor of 24. Then you have 6, 8, 12, and 24. Couple things to remember about factors. All these numbers here in the bracket, 24 can be divided by all of these numbers without leaving a remainder. So that is your definition of factors. You simply look for numbers by which 24 can be divided without leaving a remainder. And all those numbers are the factors of 24. That's the first thing. The second thing is both 1 and the number itself, 24, are automatically factors. So we begin with 1 and we always end with the number that we are talking about, in that case, 24. Okay, so let's go with set F. We got that. Let's go to set M. Multiples of 8. 8, 16, 24, and 32. Remember, both F and M are subsets of U. What does that mean? That they belong inside of that set U, and therefore the numbers that we write, for example, for M, multiples of 8 cannot exceed the last number here, 36. So we could not have continued and write 40, because of course 40 will not be a member of set U, seeing that U goes all the way up until 36. Okay, so we have listed the members of F and M. This is set M here, and this is set F here. So we have answered part 1. Draw a Venn diagram to represent the above data. Right, so let's do that. Let's draw our Venn diagram here to represent the above data. So we need to position our universal set, usually written as that rectangle, and we have 2 sets which are subsets, and they are usually represented by our circles as shown. Now, if we call this set F and we call this set M, what we need to highlight, let's look at F and M and find all those numbers that are common to both sets. 8, 16, 24, 32. So we got an 8 here and an 8 here. And we also have 24 and 24. So those two numbers that are common will be represented here. So we put 8 and we can put 24. And then let's finish up set M. 1632 can go here. 1632. And let's finish up with set F. F will be 1, 2, 3. 1, 2, 3. 4, 6. 4, 6. We already have 8 accounted for, 12, and 24. So we need to complete this diagram by putting the rest of the members of set U, which is our universal set, which are not already stated in both F and M. So let's underline those numbers here. Right, okay, so I just saw something and let's talk about it. In set F, although we list all the factors as 1, 2, 3, 4, 6, 8, 12, and 24, seeing that set U is defined only as multiples of 4, then we'll have to eliminate those members here, which are not part of the universal set. So let's do that. So we cannot give 1 as being a set F here in terms of F and M being subsets of U, because 1 is not contained in universal set. Similarly, 2 cannot be mentioned because it's not contained here. Neither can we put 3. It's not included up here in U. 4 is included, yes, it's there. What about 6? No, we cannot put 6 as well because 6 is not a member of U. So I think that is important, and let's fix it. So 1, 2, 3, and 6 will come off. 1, 2, 3, and 6 will come off. So then we are only left with 8, 12, 24, and 4, which is what we have here. 8, 12, 24, and 4. And right, 8, 16. Right, so then we are good. We are good with that. All right, so saying that we have already included the number 4 in the set. Right, let's continue. 8 is already included. We have accounted for 12 in both set of F. It's there. 16, no, yes, 16 is accounted for right here. Right. 20 is not mentioned in both F and M, so therefore we cannot. We have to put 20 outside. What else? 24, yes, 24 is already mentioned there. 28, right, so 28 must go here. 32, it's already mentioned here. What about 36? No, it's not, so let's put 36 here. So that will complete our Venn diagram. That's part 2. Right, so let's see 4, 8, 12, 16, 20, where's 20? Yes, 20 is there. 24, 28, 32, 36, good. F, right, so this will be the set F, only 8, 12, and 24, 8, 12, 24, and 4 is right here. And multiples of 8, 8, 16, 24, and 32. And it's all right here, 8, 16, 24, 32. Great. So that's the end of question number 1. Let's go to question number 2. Again, be given a Venn diagram. And let's write out our set A and our set B. So let's list them. So A consists of the numbers 2, 4, 6, 8, 10, 12, and 14. Set B consists of the numbers 3, 6, 9, and 12. Okay, so the question says U consists of the numbers of whole numbers less than 15. So let's write out U. If U consists of whole numbers less than 15, you will go all the way up to 14, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have just listed and set U. So question 1 says, describe A and B in words. Now, when we look at A really is a set of even numbers up to 14. And set B would be the set of multiples of 3 up to 12. Okay, so that's two ways of describing our A and B, our set A and B. List the members of A intersect B. So we know this symbol represents intersection, and the set A intersect B will consist of members or elements 6 and 12. So set A intersect B would be the set consisting of the members 6 and 8, not 6 and 8, 6 and 12, as shown in your diagram. And let's go to the next one. Now, when you see an N in front of your brackets, that means the number of members in that set A intersect B complement. So we'll need to figure out what is the set A intersecting the set B complement. And we already have the A written out here. That's our A. And let's write B complement. B complement means all those members outside of set B. So if we look at this carefully, it will be, let's look at the members here. It will be all these members, 2, 4, 8, 10, 14, 1, 5, 7, 11, and 13. So we need to write out all of those. Just to list them, let's list them. Not in any particular order. So let's go 2, 4, 8, 10. Then we have 14. And that will also include 1, 3, 7, 1, 5, 7, 11, 13. 1, 5, 7, 11, 13. So we barely got him in there. Okay, 1, 5, 7, 11, 13. Now, we need to look for the intersection between A and B complement. Let's write A again here. And then we look for those numbers that are common to both of them, to both sets. And we can highlight those numbers. So the number 2 is common, as well as 4. I'm seeing 8. I'm seeing 10. I'm seeing 14. 1, 5, 7, 11, 13. I think that's it. So A intersect B complement will consist of the members 2, 4, 8, 10, 2, 4, 8, 10, 14. And the number of members in that set will be 1, 2, 3, 4, 5. And that will be the answer right here. So I've shown you a step-by-step method of working out the answer for that question in part 3. So that's one method. Now, if you wish, we can also use the diagram to figure it out. So let's go. The set A intersecting B complement. So let's first shade what is B complement. B complement would be everything outside of the set B, right? And if we look at the diagram here, we know B complement would consist of all those numbers outside of the set B. So we will shade outside of the set B. So this is another method if you wish to use the diagram and you shade. So that is first your B complement, everything outside of B. Now, if that is intersecting with A, let's shade A. Right, intersecting with A would be this portion right here inside of the set A. Are you seeing that? Because that's what it says. It says A intersecting B complement. So it must be that overlapping region between B complement and A. And from there, you can write down those members. So A, from the diagram, A intersecting B complement would be the numbers 2, 4, 8, 10, and 14. Right, which is basically what we have across here. 2, 4, 8, 10, and 14 right here. And of course, the answer will remain the same. The number of members in A intersect B complement will therefore be 5. I want to make one final point here just before I move on to the other question. I want you to be very careful that you understand, and I put it right above the diagram, the number of members. All right, let me not say it just yet. What I want to say is this: A intersect B complement. Right? Let me try writing it again. A intersect B complement is not the same thing as A intersect B complement. Right? What this means is everything outside of A intersect B. So it will be everything outside of this little portion here. A intersect B, which is right here. This little middle portion here, 6 and 12. Right? So just bear that in mind. So therefore, A intersect B complement, that set will be all the other numbers outside of that region shaded in pink. And we'll see how that will come out in the next question. So let's go to question number 3. In question 3, we're given the universal set. Note, sometimes they have this symbol for universal set right here. And then they have just the U for the universal set. So your universal set is defined as 1, 3, 4, 6, 7, 8, 9, 13, 15, 19. Then you have X as 1, 3, 6, 7, 13. Y is 1, 3, 7, 13, 15, 19. And Z is 1, 3, 9, and 15. So they want us to draw a Venn diagram to represent the above information. Okay, when you work in here with 3 sets, let's see if there's any number that is common to all 3. Well, we have 1 common, and we have 3 common. And I think that's it. So it's always good to draw perhaps your 3 sets, something like this. Let's do that again. I'll show it a little bigger. This is the first circle. This is the second circle. I'll show this one as the third circle here. Right, your circles will be neater than mine. So we can call a set X, Y, and Z. Okay, so this region here in pink is where the three sets overlap. And it is in this region, you must include those two numbers that are common to both the three sets. So let's look at the diagram, not the diagram, the three sets again. And we notice the numbers 1 and 3 are common. So we must put number 1 here and number 3 here. Okay, so for completeness, let's put our rectangular box representing the universal set. And again, your rectangular box will be neater than mine. Right, so we have already dealt with 1 and 3. Now let's consider just set X and Y and see what else is common in X and Y. So apart from 1 and 3, in X and Y, we have both 7 and 13. 7 and 13. And of course, once we highlight them or underline those numbers, we are placing them into the diagram, so we know they are already accounted for. So when we consider X and Y, the 7 and 13 can go right here. So that's just common to the both. And let's finish up Y, 15 and 19 can go here. That's the rest of the set Y so far. No, not yet. Let's not do that. So my approach, because we have some of those two numbers which may be common with another set. So let's repeat how we tackle the drawing of the diagram. 1, start with where all three sets overlap, and that was shown in pink, where we put in the numbers 1 and 3. Then you take in where two sets, considering two sets at a time now, and seeing where those two sets overlap, and we starting with X and Y. And we saw the numbers 7 and 13 were common to those two sets, X and Y, and we put the 7 and 13 into the diagram. Now we go to, let's take set Y and set Z. So remember, we're taking two sets now and see where the common numbers, if any, exist, right? So let's go to Y and Z. When you look at Y and Z, you have the number 15 common in both cases. So we can put the number 15 right here. It's common to both Z and Y. So we just dealt with that. Now let's look at X and Z. The only other number is 6. There isn't any number that's common to those two sets, so we can leave that region blank. Once you have completed that exercise where you're looking at two sets at a time, then you now look at the individual set, and whichever number is not accounted for in the diagram, you simply write it in. So let's start with X. We have already put in 1, 3, 7, and 13. So therefore, the other number 6 can simply go here. Let's go to Y. We have placed 1, 3, 7, 13, 15. So the number 19 now could be placed now right here. Let's go to Z. We have already accounted for 1, 3, and 15. So the number 9 can be placed here. So that's how you approach drawing the Venn diagram. Now, once all the members or elements of X, Y, and Z are accounted for in the diagram, then we can underline those numbers. Let's go 1, 3. 4 was not common here. Let's go to 6 was accounted for. So was 7. Nothing with 8. 9 was already placed. 13, 15, 19. So the other two numbers, 4 and 8, which is not represented in the Venn diagram so far, they will go outside. 4, anyway, outside of the three circles are shown. And that will complete the actual Venn diagram. Okay, let's go to part 2. List the members of X complement union Y. X complement is everything outside of X. everything outside of X. So let's just shade X, and we are looking for all those numbers outside of X. So X will be all the way around here. All the way around, we shaded the entire circle representing X. Right, the entire circle. And everything outside of that circle will represent the complement of X. So we can see it clearly now. So X complement. Now this is the preferred approach I would take. I would write down my members of X complement, and that will consist of the numbers 9, 15, 19, 8, and 4. It doesn't matter the order in which you write it. 9, 15, 19, 8, and 4. Right, and now we can state the set Y. It's already stated up here. And Y is 1, 3, 7, 13, 15, and 19. And if you ask to write the union, think about marriage, two parties coming together, union being united as one, then you can combine those two sets, X complement union Y. And if there's any number that's repeated twice, you simply write it once. So let's start with X. Again, you need not write it in any order. X complement, sorry, is 9, 15, 19, 8, 4. And let's just continue putting the rest of the members now. 1, 3, 7, 1, 3, 7, 13. 15 is already mentioned up here, so we need to write it again. It's already stated here. 19 as well is already stated here. And we can simply close or end the set like that. So that would be X complement union Y. Now let's go to the last part, which is asking us to state the number of members in Z intersect X complement. Right, and I was talking about that earlier. Z intersect X complement. What you do, first of all, let's isolate Z intersect X. Z intersect X will be that common region to both, or that region common to both Z and X. So let's find the set Z, there it is. And let's find the set X. Let's see where they overlap. They overlap right here. That's the common region right here. Right. Z and X only. Right. So that's the common region. Right. And everything outside of that Z intersect X complement will be the answer right there. So we can write it. Let's see if we can get enough space to put that down. This will be the set consisting of the numbers in any order 6, 7, 13, right? 6, 7, 13, 19, 15, 19, 15. That's here. Then we have 8, 4, 9. 8, 4, 9. And we can close it right there. Okay, so that will be your answer for part 3. Wow, I had fun doing these questions. And that will bring us to the end of this question and answer segment. Thank you so much for joining us. Until then, may God continue to bless you. Bye for now. I'm Teacher Olton.